Okay, Tesveen, please
Yes,
tell me how piezoelectric effect works.
Alright, so piezoelectric effect. So basically, the crystal converts electrical signal into pulses and echo it's back to electrical signal.
Okay, so it converts echo into the electric signal, which is direct piezoelectric effect, and then electric signal into the sound wave, electrical energy into mechanical energy, which is reverse piezoelectric effect. Okay, what is the value of speed of sound in tissues?
The 1540
1540 meter per second. Okay, what is the value in millimeter per microsecond?
1.54 millimeter per second.
Okay, Dr. Avadia, when we increase image depth, what happens with the frame rate? Increase or decrease?
Decrease.
Yes, it will decrease.
Decrease.
Exactly.
Yes.
Okay, Tesveen, what is the reciprocal of the mega?
Reciprocal omega times micro.
Okay, good. Dr. Avadia, what is the reciprocal of the giga?
Million.
Reciprocal of the giga is?
Million.
Mega is equal to million. Reciprocal of the mega is micro, which is million.
Yes. Is micro, yes.
So, giga is equal to billion. Its reciprocal is?
Yes.
Nano.
Billion.
Nano, which is equal
Yes.
to billionth. Nano is billionth and giga is billion.
Million is the billion.
Okay. Tesveen, convert 7 gigahertz into megahertz.
Giga to mega would be 700 megahertz.
Okay, Dr. Avadia, what do you think?
7 divided by 1,000.
We are going from giga to
Point
mega.
0.77. أيوة. From large, from small to large.
Large to small. Giga 10 raised to power 9 to mega 10 raised to power 6.
From large to small, yes.
So, we will multiply or divide?
We are divide.
When we go from large to small,
multiply, yes. We are multiply.
we multiply so that it does not
Multiply by
become
1,000.
too small. So, we multiply by which number?
1,000.
Yes, 1000. So, this means 7 multiply 1000. Answer will be
1,000.
7000 megahertz. Okay. So, this means sound is mechanical wave or longitudinal?
Longitudinal.
Yes, longitudinal.
It's both. It's mechanical and longitudinal wave.
Yes, longitudinal, and also it is mechanical wave and it is not transverse wave. So it is mechanical, longitudinal energy, also it is pressure wave. Dr. Avadia, what is the frequency range which we use in diagnostic ultrasound?
2 to 15 megahertz.
Yes, it is in megahertz. And what is the unit of Doppler shift?
Kilohertz.
Exactly, kilohertz. Okay, Tesween, what are the key properties of the sound?
Okay, so three properties of sound. Okay, so we have amplitude. Okay.
Yes.
No wait, key properties of the sound.
Yes, amplitude.
Amplitude, power, intensity. Wait, I thought this also tells the strength of the wave.
Yes.
Okay, and then
Amplitude tells us about the strength of the vibration,
wave.
strength of the wave.
So there's amplitude, which is the height of the wave, and then so there's amplitude, and then there's the power, which is the energy transferred, and then intensity is the power over area.
Power is energy transferred per unit time. Intensity is energy spread over an area. What are other key properties?
There's wavelength, which is the distance of one cycle.
Okay, good.
There's frequency, which is the number of cycles per second.
Okay.
And after that, we have velocity, how fast the sound travels in medium, and period, which
Okay.
is the time of one cycle.
Okay. So what is the relationship between the frequency and wavelength?
Inversely related.
Okay. Dr. Awadia, what is the relationship between frequency and period?
Inversely related.
Yes, inversely related. So this means pressure is high in compression or rarefaction. Which region?
Compression.
Okay, compression, good. So in this wave, there are 2 points A and B. So which point shows compression, A or B?
A.
Yes, A. It is also known as?
Crest.
Yes, good, crest. And B is also known as?
Rho.
Yes. And trough shows region of rarefaction. Okay, good. Dr. Awadia, if we have to choose frequency, so we will prefer on basis of like first factor we consider will be tissue penetration or resolution.
Tissue penetration.
Yes, first is penetration and then comes resolution.
Resolution. Yes.
Okay, good. And typical frequency range for general abdominal ultrasound is?
2.5 to 5 megahertz.
Okay, good. This means which frequency is most suitable for imaging the eye?
Yeah. That means it's a shallow region. High frequency.
2 to 3, 3 to 5, 5 to 10, 7 to 15 megahertz.
High frequency. 2 to 3.
Which one?
2 to 3.
Are you sure?
7 to 15. 7 to 15.
I mean it's,
The superficial
yes, it's
structure.
superficial. So which one is better? 7 to 15 megahertz is better.
15.
Okay, good. Now we will start our next topic. It is about speed of sound. So what is speed of sound? Its formula is distance divided by time. So the rate at which sound energy moves through a medium is the speed of the sound, also known as propagation speed. And sound needs a medium.
Propagation.
Yes. Sound is unable to move in space, in vacuum where there are no particles. So it needs a medium. And each particle push the next one, passing on the energy. So particles itself does not travel from A point to B. They just oscillate. So think of it like a wave crust moving through the ocean. The crust moves forward at a fixed speed depending on the water. So speed of sound simply means how fast sound energy moves through a material. And we call it propagation speed as well. And its formula is speed is equal to distance divided by time. From this formula, if we rearrange it, we can calculate the time, which is equal to distance by speed, or the distance, which is speed multiplied time. Tesveen, what formula for the distance calculation we use in ultrasound?
What distance?
Distance the echo travels. Distance
So, yes.
to calculate distance of the object.
Measuring how far the echo travels.
Like if we want to calculate distance of an object where it is placed inside the body, so what formula we use?
Speed of sound divided by frequency.
No, that is a formula for the lambda wavelength. We want to calculate the distance of an object. Formula is
Speed multiplied by time.
the same formula. Distance formula will obviously same. So distance. So in our formula, two things matter: v and t, right? Distance is equal to speed multiplied time. Because speed is linked to distance and time. Distance divided by time. When we have to calculate distance, we will cross multiply time here. So distance is equal to speed multiplied time. But in ultrasound, to calculate the distance of the object, what's the difference? We simply divide it by 2. Why we divide it by 2, Dr. Awadia?
To go retain time because the echo travel and then retain.
Yes.
Two time.
Yes,
fraction
because pulse first goes and then comes back. This is the go return time, but we need only one-sided time, the return time. So this T represents go return time. For pulse to travel and then echo to return, but we need only one side time. So we divide it by 2. Please remember this formula. This is very important. D is equal to V multiplied T divided by 2. Very important for exam. Okay, so to calculate the speed, formula is distance divided by time. In ultrasound, speed of sound in tissues is constant. Speed depends on the medium, does not depend on frequency, does not depend on the wavelength. So a 5 MHz probe and 10 MHz probe both travel in both speed of sound in soft tissues is equal at 1540 meter per second. Now there are different mediums. General, like we are going to discuss generally what happens. There are different type of medium: liquid, solid, and gas. This means, what do you think? Speed of sound will be fastest in which medium?
Solid.
Exactly, in solid. Dr. Awadhi, what is the reason? Why it is fastest in solids?
Because it has high density. The speed of sound dependent on density and compressibility of the media, or stiffness and compressibility. It's highest. It's more. It has more stiffness.
The main factor is stiffness.
Stiffness. Yes, stiffness. Because the solid is stiffer than liquid and gas.
Yes. So, what is the meaning of stiffness? This means how hard it is to squeeze a material. If it's stiff, it will resist compression, right? It does not move from its place easily if it is stiff or solid. Like a spring, we can easily squeeze its component. It means that is less stiff. But if there is a steel rod, it's very hard to squeeze it, obviously. So it's more stiff. More stiff means particles are more close to each other, and because they are more close to each other, they pass the vibrations very quickly. So speed of sound is fastest in solids because in solids molecules are very close to each other and they are more stiff. So that's why they pass the vibrations quickly. So stiffer the medium, faster the sound travels. Also, one other factor is density. Density means how heavy or tightly packed the particles are. If the particles are very heavy, it's harder to move them. So the waves slows down. It means higher density means speed of sound will be less. But the main factor is the stiffness. So because solids, they are more stiff. Particles are more close to each other. Their bonding forces are more strong. So that's why speed of sound is highest in the solid. And it is slowest in which medium, this mean?
Gas.
In gas, because we can see particles are away from each other and their connecting forces or bonding forces, they are weak. So that's why speed of sound is lowest in the gases and highest in the solids. And what about liquids, Tata Awadhya?
It's in between.
In between. So it is less as compared to the solids and more as compared to the gases. So speed of sound is very slow in air, around 330 meter per second. So during lightning, what happens? First, you see the lightning before you hear the thunder. First, you can see the lightning and then you can hear the sound of the thunder, because speed of sound is very slow in air, around 330 meter per second, and it is extremely fast in bones, nearly 4000 meter per second, because bone is very stiff. Sound needs a substance to travel through and travels by particles vibrating. So which state of matter does sound travel fastest? That is solid. Because in solid, particles are very close to each other and vibrations are very easily passed from one particle to other particle, and sound travels faster. So here we can see the value of speed of sound in different tissues. It is very important. So first of all, speed in air is slow, 330 meter per second. In bone, it is fastest, 4000. Soft tissue, it is usually around 1540 meter per second. What about transducer crystal? Crystal, because it is solid, so again it is high in the crystal, 3850 meter per second. These values are most important. Air, 330. Bone, 4000. And then transducer crystal, again very high, 3850. And soft tissue, we already know it is average, 1540 meter per second. Now in fat, it is slower than tissues, 1460. In muscles, it is slightly faster than the tissues, 1580. So we should also know about fat and muscles, because their speed is slightly different as compared to the soft tissue. But machine assume their speed is same, equal to the soft tissue speed. And this is a wrong assumption, because actually their speed differs. So Dr. Awadia, what do you think? What happens in result of this wrong assumption?
I think she left.
Okay, Tasween. Then what's your opinion about this?
That means this may be a miscalculation.
Okay, yes, exactly, miscalculations of the distance. Because distance calculation depends on the speed. So now, because machine assumes the wrong speed, so there are wrong calculations of the distance. So what happens in result of that?
An object is placed according not appropriately.
Yes, exactly. The object is not placed appropriately. Either echoes are displayed deep or superficial. So in fact, speed of the sound is actually slow than the tissues. So their echoes will be deep or shallow because of the wrong calculations.
It'd be shallow.
Actually, it is deep because speed is slow, right? It's taking now more time to go back. So echoes are placed deeper as compared to their original location. And in muscles, because speed of sound is slightly more than the tissues, so their echoes are placed shallow because their speed is slightly fast, so they will return slightly quickly as compared to the soft tissues. So that's why their echoes are placed shallow. And then there are some other values, just give them a read. In water at 20 degrees Celsius, their value is 1480 meter per second, and for 6% saline, its value is 1540 meter per second. So it is used as a calibration standard because it is equal to 1540 meter per second.
Okay.
So what's the trend? The speed of sound is fastest in stiff solids like bone and crystal, slowest in compressible gases like air. So in solids, speed is more as compared to the liquids, and in liquids it is more as compared to the gases. Here we can see the same concept. And when there is no medium, then there is no sound because it requires a medium. And it travels fast in the solid and slow in the gas. So in gas fast, liquid faster, and solid fastest because molecules are more close to each other. Okay, now there are two medium properties which determine speed of sound. First one, and the most important one, is the stiffness or elasticity. And another one is the density. Stiffness means tightly bound molecules, and more they are tightly bound, more they are stiff, more molecules are close toward each other, energy passes more quickly, speed of sound increases. For example, steel versus rubber band. So in steel, vibrations pass very fast as compared to the rubber band. Density, heavier medium means harder to move molecules, so speed will be less. And example is light versus heavy backpack. So heavier is harder to shake. So bones, they are both stiff. So particles are more close to each other. So it means they are more dense as well. But the main factor which influence, according to this principle, because the bones, they are more dense, speed of sound is less. But no, because they are more stiff as well. So the main factor you have to consider is the stiffness. Stiffness is the most important factor. So because bones are more stiff, so it means speed of sound will be more in solids. Now what's their formula? Speed directly proportional to stiffness, inversely proportional to density. More stiffness, more speed, and increased density means less speed. And what matters more is the stiffness. And we also know one thing, stiffness is inversely proportional to elasticity or compressibility. So we can also write this formula as, in place of stiffness we can write 1 divided by elasticity or 1 divided by compressibility. So this way we will get two new formulas. So whole this topic is very important for exam. And also these three formulas are important. So speed is directly proportional to stiffness. It is inversely proportional to compressibility, inversely proportional to elasticity, and also inversely proportional to density. So in solid, because molecules are tightly bound, speed of sound is highest. In gases, weakly bound, speed of sound is slowest. In liquids, speed of sound is in between. So it is fastest in solids, slowest in the gases. Okay, now propagation speed artifact. Dr. Awadia, can you please explain what is the propagation speed artifact?
The sound assume generally the speed of sound in a soft tissue. If the speed of sound is differs, then the propagation speed artifact of the will significantly differ. For example, when less than the speed of sound in soft tissue, an echo should be seen deeper than relayed. And if more or faster than soft tissue, echo will be seen superficial than its real location.
Okay, good. It is also known as misregistration artifact. Propagation speed artifact are misregistration artifact, and it is very much important for the exam. Okay, Tesween, why echoes from fat they are placed deep than their original location? What's the reason?
Because the propagation speed of fat is slower than speed of sound in tissue.
And it will take more time to return. So that's why it is placed deeper. And in muscles, because speed is faster, so echoes will travel back faster in less time. So
Yes, sure.
they are placed shallow as compared to their original location. Okay, now here are key points. Dr. Awadia, please repeat them.
The speed of sound equal distance divided by time.
Okay, controlled by medium
Controlled
properties.
only by other factors. The medium properties such as stiffness and density. It was higher in more stiffer material, and more dense material have low speed. Soft tissue standard speed of sound 1.54 millimeter per microsecond, or 1540 meter divided by second. It was more in a solid than a liquid than a gas. Clinical important, wrong assumption, speed of sound artifact.
Hi everyone, I am Hina Wajid and I have passed my ARDMS exam with 94% marks in SPI and 94% marks in OBGYN. Now here on YouTube, I share SPI related MCQs and tips to help others pass ARDMS exam too. If you want full SPI session and all topics explanation according to ARDMS content outline and their syllabus, then you can find the link in the comments to check some of the free PDFs, some of the free videos, and you will also find details how to contact us to join our complete session.